Thanks everyone, welcome back to the channel. Till now, we saw how containers inside the same pod can share data using MTDAR. That sharing was happening only inside the pod. Now, let's move one level outside the pod and connect our container directly to the host mission. Think about this is like a simple bridge. One side is your container and the other side your node mission. The bridge between them is called as hostPath volume. This is the one which can be useful volume type in Kubernetes. So whatever happens inside the container, you can see it on the host mission, and whatever existing on the host mission, you can see it inside the container. Now I will create one pod and connect it to a folder on the host mission. This folder can be anything you want. For demo purpose, I am using /var /k8s/data on the host mission and /app/data on the inside container. Okay. You can change these paths as per your setup or as per your requirement. So the same YAML file can be used for live demo now. So let me explain this file in simple way. We are creating a pod named as host path demo. Inside this pod, we run one container using Ubuntu latest Docker image, and the container name is C1. Then we can keep it running this container with the sleep command so that we can go inside this container and we can perform our live demo, or we can execute the required commands to perform the live demo. Then we define one volume at the pod level and name it as shared storage. Then the type of this volume is hosted path, which means it connect to a real folder on the host mission. The path on the host mission is /var/k8s-data. If this folder does not exist, Kubernetes will create it automatically using type directory or create. And what we can do, the same volume is mounted inside the container at /app/data. So both of these paths are actually pointed to the same storage. Files created in one place appears in the other place. Okay. Now let's do the live demo. So once the live demo is done, we will focus on where and all this host path can be useful in our day-to-day activities and what are those use cases. Okay. Now let's apply this file and create the pod and see the live demo. So before going to that, so here are the same commands we are going to perform, and we will see how this demo can be working. So this is the code just now we have seen, and here are the couple of commands we are going to execute now. So before going to apply, let me verify the path which we are configured inside the code. See now the folder is not available. So the moment when we can enter this command, the path will be automatically created. Now ls-lrt var k8. See now the path is created, but it is empty because it is freshly created. Now the pod is running. I will check the mounted folder inside the container. So at this point, the folder is empty because this is a fresh directory on the host mission is created. Now, if you want, you can verify using kubectl exec, the pod name -c, the container name --ls space /app/data. It is empty because even if you can verify, the folder is freshly created on the host mission, the host mission also should be empty. Now I will create a file from inside the container. Let's see what happened. This is the command we are going to use to create a file from inside the container. kubectl or kubectl exec, the pod name -c container name, and we are using touch and create the file under the mounted path, which is container file.txt. If we enter, you can see the file inside the container. This file is not only inside the container, it is also created on the host mission. Let's check quickly. So let me execute this again. See, the file is available inside the container one, and you can enter the same command on the host level. The file is available in the host path as well. Okay. Now I will create one file directly on the host mission and check if it is appear inside the container. So for that, what we can do here, the command touch space host path is /var k8s/data host file.txt. Now earlier we have verified only one file is available. The moment if we enter this command, now if we can verify, there are two files are available. Okay. So you can see again inside the container whether this file is appear or not. Now you can go and verify. See here, you can see both files inside the container. This confirms that the container and the host missions are sharing the same data using host path volume. Okay, even if we can try to delete one file from the host path, and same thing should be applicable in the container as well, because they are sharing the same volume. Now I have deleted host path file from the host mission path. Now if we can verify, only one file is available inside the host mission, and if we can go and verify in the container one also, only one file is available. Now notice one important thing here. If the container restarts, the pod is still there. The host path volume also is still connected and the data is still available. Even if the pod is deleted and recreated on the same node, the folder on the host mission still exists. So that is where the data will be still available. This is quickly different from the mtdir, where in the mtdir, if the pod is deleted, the data is disappear. When the pod is recreated also, the data should not be available in the mtdir volume. But here the case is different. If the pod is deleted and recreated on the same mission, the same data should be reflected in the container because the host path is not deleted. Now you can go and quickly check kubectl get parts, kubectl delete pod, and you can give the pod name. Even if you can delete the pod, the host path content is available. If we recreate on the same node, then the pod should be get the same content which is available into the host path. Okay. Now the pod is deleted. You can check ls space -lrt var k8s/data. Now see, the data is available. It's not deleted. kubectl get parts, the pod is deleted. If you try to recreate the pod on the same node, you can get the same data onto that container one. Okay, let me execute that one. kubectl apply -f hostpath.yml. Now the pod is created. You can see here kubectl get parts. Now the pod is running. Then after that, you can verify the content is same or not. Now see, the content is available. Okay, this is why host path volume is useful when you want your container to directly work with files on the node mission. Okay, for example, logs, debugging files, local testing, demos are tools that you need access to host level folders. That case, it gives a simple and fast way to connect to the pod storage with the host storage. Okay, so once you see this demo live, the idea of that host path volume becomes very clear. The pod connects to the host folder and the data flows naturally between the container and host path. Okay, finally, we can clean up this one. kubectl delete, okay, -f hostpath.yaml. Then the pod will be deleted, but the folder on the host machine will still be there with the files. That's the behavior of host path volume in Kubernetes. So in the next video, we will move one step ahead and see how persistent volume work so that data is not tied to a single node. kubectl get parts. Now see the part is deleted. Now you can verify here. See the data is available. Now let's talk about the real-time benefits where in our day-to-day real-time use cases we can use this. The biggest benefit of host path is direct access to the host mission data. So you no need to copy, you no need to do the syncing, you no need to exporting. Just one folder shared between the container and host. This is the first benefit when we are using the host path. And the second benefit is data stays the even if the pod is deleted. As long as the folder on the host machine remains, the data should not be deleted. This is very different from the mtdir, where in the mtdir the data is disappears when the pod is deleted. Okay, so the data physically lives on the node machine. It's not in the pod machine. Okay. The third benefit is if you want to do the fast setup and with the simple way, we can use this host path volume. You don't need any storage class, external storage or cloud disk. You just point to a folder on the mission, then you can start using it. It is not meant to be used as a general storage solution for production workloads across the multiple nodes because host path is tied to one specific mission. If your pod moves to another node, that folder will not exist. So this is where host path volume is very important in Kubernetes. And host path is also useful when you want to share configuration files from the host machine. For example, imagine you already have some configuration files or scripts on the host machine. Instead of rebuilding the Docker image, you mount that folder into the container. The container starts using those files directly and it can be executing whenever it is required. And another use case is when some tools or agents need direct access to the host level paths. For example, node level monitoring agents, file scanners, or system utilities. These tools need to see what's happening on the host machine. That case, host path allows the container to look into the specific host directories into the controlled way. Now, one important thing you need to remember is host path volume is majorly used for we can do the node level tools, temporary setups, development phase, and we can use debugging time even if you want to do demos or learning. Okay, in the next class, we will see persistence volume. If this video is helpful, could you please do like, share, and subscribe? Thanks for watching.